Hi, this is a brief introduction to the difference between a class and an object. Modern programming approach to software development is through the use of objects, and the approach is called object-oriented programming. So an object is something that has certain attributes and certain behavior. Let's consider a student as an object. So what are some of the attributes and the behavior? A definite attribute of a student is a student has an ID and a student has a name. So we say this is a behavior. These we call as the attributes. So you may want to change the name, or you might want to change the ID of a student. So we need certain behavior to change name, or to set the name, set an ID as well. To do that, in Python we use the keyword class, and that's shown here. The keyword class identifies the beginning of a definition of a type of entity, and the name of this type is given as student. Actually, we use the word class to define the type of entity. So class represents the definition of a structure, that for the attributes and the behavior of a type of entity. In this case, the type of entity is student, the type is student, and the definition starts on line 1 and ends on line 22. We know that anything within these lines belongs to the class student. So it contains the attributes as well as the behavior. So where are the attributes defined, and what is a behavior? A behavior is nothing but a function that exists within the class. So any function that exists within the class is a behavior. And when we talk in terms of classes, we do not call them functions anymore, we call them as methods. So there is a method getID on line 12 and ending on line 13. Similarly, we have another method getName, another method getSetID, another method setName, plus a special method that starts on line 2 and ends on line 11, and that's the init method. So in here we've got 5 methods: init, getID. We generally call them as behaviors of this class called student. Similarly, here we have self.id and self.name. Now this self refers to an object that is under consideration, and .name represents the attribute of that entity. ID is another attribute. So by defining these within the class student that starts on line 1 and that ends on line 22, since these definitions end on line 1 and line 22, we say they belong to the same class. So any behavior that is defined between the use of the keyword class and the corresponding end of that class we say belongs to the definition of that class. We know that the definition starts on 1 and ends on line 22 because of the indentation. Observe that the indentation of the statement on star 24 is on the same level as that of line 1. Hence we know that the statement on line 24 does not belong to the class student. Every class has a method called init, and which has got two leading underscores followed by the name init followed by two trailing underscores. The init method is a special method, and the general term for such a method is called constructor. So the word constructor is used to define the attributes, or to give or initialize the attributes of the class. Let's see what happens. So when the program gets executed, this control will first come to line 1, and then it knows that it is the definition, so it skips all that and sees all those lines following it until it reaches a line that is beyond the class. So it comes to line 24. So when line 24 gets executed, this statement gets executed. It actually invokes the constructor. So even though it's not written as, when we invoke, we do not write it as something like s is equal to __ init. We do not do that. Rather, we write this as s is equal to student followed by the whatever parameters, arguments you need to pass. So when this gets executed, the control goes to the constructor, and the constructor is the one that gets executed. So when this gets executed, memory is allocated for an object, and that object will be referenced by s. Now when I say memory gets allocated for the attributes. Now from this code, it is evident that there are only two attributes, because self.id and self.name are the only attributes that are available there. So memory is allocated for the object for the attribute id and for the attribute name. So in here, when the control gets transferred from 24 to line 9, self.id is assigned to whatever parameter id is. So id would take the value of S007. So S007 is the argument, and that will be transferred to this parameter id. And when this statement gets executed, self.id refers to this id. This, when line number 9 gets executed, it refers to this argument. Similarly, this would refer to Chris, argument Chris. Now you would have noticed that this statement has got only two parameters, whereas the corresponding formal parameter has got three parameters. That is very typical in Python. In Python, the first parameter offered within a method in a class refers to the object itself. In other words, when it sees student, which has got the same name as the class name, so this refers to student which has got the same name as the class name, it knows that this student object will be assigned to the variable self. So self will be assigned to that, and then it would then be set using the attribute. So if moment you write self dot, it means it is the attribute of that class that needs to be used, whereas id here doesn't have self here, so this is a different variable than this id. So that's what happens. Now suppose you had, following line 24, suppose you had, say, S2 is equal to student, let's say 1, or rather S001, followed by, let's say, Jack. Now another student is created, so memory gets allocated for another object. S2 would refer to this. Now this object has its own attributes, so memory would be allocated for ID here and another variable name. Now you see, these are different allocations from the one that we have here. So that is why we say two different objects are now created. So this object was created when line 24 got executed, and suppose there was next statement following 24, this was the next statement, then we can say that another object gets created, and then of course this would refer to S001, and this would refer to Jack. This would refer to Jack. So clearly we see we are treating as if the ID and the name belongs to an entity, and we're not treating it as independent of the entity. Hence, if we want to refer to, let's say, the ID of the second student, we would write this as S2 dot ID, and suppose you want to print, you would write print S2 dot ID. So this would print the values of the second student, and it would print S001. Whereas suppose I had written this as S1 dot ID, it would print S007. So the fact that S1 refers to the first object and S2, or rather S belongs to the first object and S2 belongs to the second object, clearly identifies the two different objects that are being used. Hence it is much more easier to think of them in terms of entities rather than being variables that are not related to an entity.